Hello everybody and welcome to a bit of a different video. I have been experimenting with Rhino 7's new SubD tools, and today I wanted to put together a demonstration that really showcased exactly what we could produce using these new tools. And the example that I'm going to use is going to be a construction of a pen dock. And I found a very interesting needle bearing that I wanted to try to integrate into a product. And it seemed to me that the form language of this product really could be something truly unique and different. And rather than traditional NURBS surfaces, what you're looking at right here is a constructed base made of NURBS surfaces. And this red piece right here you can see is the bearing itself that I plan to install into the base of this pen dock. But this is all traditional NURBS development. These were made via our normal types of cylinder and lofting tools and basic trims and cuts and deletings. Everything is as normal here. However, that's mainly not the focus of the day. The focus of the day is going to be the development of a different surface. Now it does have to integrate with NURBS surfaces, and you can see these purple elements here are two ink bottles that I want to store in the center. And I'm just blocking out the basic necessary areas that I need to address. I also want to hold several different diameters of pen, so I have those spec'd out at 12 and 15 millimeters. And I will use those later once we've created our surface to create some pockets and spaces for the pens to kind of exist within that structure and that base. Now, what we're really talking about here is SubD tools. And I've moved to the SubD tab, and you can see that we have a wide array of tools. Some of them may look familiar. I can see that we've got the basics of creation tools, and what we're going to be doing here and what we're going to be creating is going to be a new type of surface, and it's called SubD. And the idea is this. SubD modeling allows an increased level of editability. And there is a sacrifice of precision, and we'll move through when we're making this product a few demonstrations. The first one I'm just going to do is create a box, and you're going to see the difference between a NURBS box made of curves and a SubD box. As you can see, it's it's box-ish. It's not exactly a box. However, we can toggle our SubD display on and off, and now you can see what we would traditionally assume would be that cubic form. But with SubD, we're able to interpolate and smooth over those results just with a simple toggle. And you can see we have lots of different tools for changing where our edges are, adding creases, removing creases. We can loft and rail and create ellipses and spheres, cylinders, truncated cones, all the things that we have in NURBS. What I'm doing now is selecting the actual vertices. So you can select edges and vertices and then live transform them. And the object will deform all of its surrounding geometry to accommodate. And while that's not super impressive, as you can see, we can select faces. Now, what I'm doing here on the keyboard here is I'm holding down Shift and Control. This is your new hotkey when you want to work with SubD. Shift and Control allows you to select any faces as well as vertices or points for us to live transform. And then you see swapping back to display mode means that we can SubD display exactly that smoothing action while still conforming to, well, a more traditional geometry set. So I'm going to do a cylinder here, and there's going to be a compromise. You're going to see that when we create the cylinder, the points that we start from, center to edge, they're not going to be exactly where the cylinder is set. We're going to have to do a little bit of scaling after the fact. See how I'm setting it to this exterior edge here? And then when we select it, the made cylinder will be ever so slightly smaller because of that smoothing action. See? There we go. Now, right off the bat, we have a really nice, beautiful tangential curved surfaces, but you can see that the cylinder is made up of several facets when we swap out to our facet mode. And you can see that the edge of my click actually moved to the edge of that corner, and when we smooth it, it moves in farther. So there will be a little bit of scaling we have to do to make this happen. Now, for now, the first thing we need to do is we need to, well, establish that bottom geometry. And there's a tool here called Crease and Uncrease. It'll add a crease or remove a crease. And by the way, this is something that we can do back and forth at will. Now you're seeing me hold down that Shift Control. Notice on the second time I did it, it went all the way around the entire edge loop. That was because of a double click command allows you to make an edge loop selection, whereas a single click will be a single edge. All right, now that our edge has been crisped up and it is more in line with the geometry we need from the base. I mean, this is going to be a precision 3D printed structure, and I have a precision bearing that's going to fit into that little pocket. So I do want to make sure things are, well, as accurate and clean as humanly possible. Now here really comes to the meat of SubD. And the reason why I think SubD has a lot of value for designers is not because it's going to replace NURBS modeling. NURBS modeling is going to be the way that we define surfaces with curves with the greatest level of precision and flexibility. But as you can see, I'm actually being able to select faces, and I can actually add subdivisions to this space. Now we could do that with a NURBS surface, but we're going to fracture that into several different surfaces. And this modeling is trying to show us that we could make live changes to that surface via subdivision, or in a second here, we're going to apply a SubD extrusion. And what this means is that using a single surface, we can establish some level of relationship between every single facet and every single edge. And that means that we are never going to fillet anything ever again on a SubD surface. Well, we might do a little blending, but for the most part, you can see that I can select individual faces, and then via our extrusion command, I can literally insert more faces as an extrusion. And when we left click this selection, you'll see that it's actually built out surrounding surfaces and also done the blended tangential relationship between those new surfaces. Really butter smooth. Now I want a little more definition at the edge here, so we are going to do yet another extrusion. And you'll see that everywhere I have vertices and lines, I have more geometry. So now those protrusions are a bit more crisp, and swapping back into our toggled mode, you can see that they are trapezoidal and that they have an edge loop right near their edge. All right, here we go. We're going to do all of these selections, and then by shifting them closer to each other, we establish something that's more traditionally associated with like a filleted edge. Now, I did make a little mistake here. I don't want to tuck that geometry in. I always want to kind of keep it as normal as possible, and that will keep us from possibly tearing our surface at the end. And it is going to be a 3D printable surface, so I don't want to push it too hard. But the goal of this demonstration wasn't really to show you everything SubD can do. Honestly, I'm just myself beginning to play around with some of these tools. But the power, I mean, we're simply using a scale command, and we're getting, I mean, that would take 20, 30 minutes of NURBS work just to produce that. And then with a simple twist, be able to maintain that flow from part to part. I really just don't think you could do that with a NURBS modeler in any near the same amount of time. The next thing I want to impress upon is everything in this demonstration is basically three tools: subdivide, select, extrude, and then using the gumball to shift and move things around. So three major tools is going to be capable of producing this entire shape. Now, one thing I haven't quite figured out is how to extrude in a symmetrical axial direction. So I am kind of cheesing this a little bit by extruding up, selecting, and then moving that selection down and expanding. It was a perfectly fine workaround for this demonstration, but I think that there are a few other tools in terms of positional locality that I'm going to be experimenting with in order to give myself more definition and control. Something that I find is a real efficiency builder in a model like this is understanding exactly what your selections do to how slow you move. So you'll see one thing that I'm constantly doing is whenever possible, when I have edges or faces selected that I'm trying to transform, I try and do as much of that as possible while I'm there. Notice I moved from the scale and extrusion back into the second extrusion, and then now again I have to go back in and do manual selecting. So that's the most time-consuming part of this process, is just the manual selection in order to control 8 separate nodes. Now, philosophically, another thing I'm thinking here is, well, I do have to fit pens into all these locations, and having them at these kind of organic, extraordinary angles will make for quite an impressive and easily accessible pen dock. But at the same time, we need to make sure that there are clearances for everything. And because everything is negotiable as a D-sub surface, even if I was unhappy with the current shape of it, there's nothing stopping me from completely re-editing that surface, deleting faces, joining faces, subdividing faces, adding more detail where I need more detail, pushing and pulling and expanding. I have yet to find a real limitation here for what I can't create more detail and more surface geometry while also maintaining beautiful G4 and G5 class surfaces. In a second here, we're going to get to this point where we need to actually think about how we're going to 3D print this object, how we're going to start cutting in holes. And I will admit, D-sub does not have a lot of really great precision booleaning, because if you think about it, the surface that we're looking at, see, back to our faceted mode and then toggling back to SubD, that is the actual geometry. And until the SubD becomes converted into a NURBS surface, it doesn't have any editability capabilities with NURBS objects. So the ring and the base and the bearing that I created down there are functionally useless to us until we're done editing the SubD. So I will say that so far my understanding of the workflow is that you spend a significant amount of time in your SubD tools making really fluid dynamic changes. And then you check those surfaces with your NURBS surfaces to make sure that the clearances and relationships are as expected. So for instance, here I need to make clearance for the ink bottles. So I'm subdividing the center of the cylinder, selecting a square-ish shape, and then I'm going to extrude downwards in order to create this pocket that the ink will fill into. But definitely the workflow here is considered a then B type of situation. I think that it would be possible to create a SubD surface, edit it, then bring it back into SubD, make edits, and go back to NURBS. I have not had a huge amount of success with that yet. So that is one thing I am currently still trying to figure out the workflow for. So right now it's SubD, then NURBS. But I think that with some careful organization, there may be some back and forth crosstalk. Now, one thing I noticed when I was editing these faces is that, well, it fits the bottles, as you can see, but not as tightly as I would like. So I thought, well, I can't really make the bottom any smaller, but then I realized that there was a ring of CVs, although they were difficult to see. And then I saw, oh, well, it's actually very organized. If I just select all of these edges and I do a scaling command to bring myself in, I should be able to neck in the orifice at the top more than at the bottom. And that's exactly what it allowed me to do. I don't even know how I would do that with NURBS. I mean, that would be an hour at least. And to get that level of smoothness, the control point control of your curves would have to be flawless. And you would just be building so many structures in so many little helper structures in NURBS just to make that it would just, I just wouldn't be worth it to me unless I was sure this was the final form I wanted. And that's what I've been so excited with SubD is I did this entire model in 20 minutes from start to finish. And with 3D printing, after a few days, I was able to have a really short innovation cycle in terms of when I thought about making this to when I actually started making this. It pretty much happened almost immediately. And that's something I can see as a real value for designers. NURBS surfaces have some amazing benefits of precision, and when we're making prototypes, it's very helpful to have this extreme dimensionality, and it's very helpful to have an exactitude in terms of understanding where parts are, especially with assemblies and mechanisms. But with form development, it's so much more of an editing and conversational element. And at this point, we have edited this structure back and forth far beyond what we normally would be able to do. Now, at this point, I want to go back to NURBS because, as you saw, I've got the bottom ring all set up, and I want to cut it in and make a closed poly surface. So there is a tool for that. You can see it is called Convert Objects to NURBS, and Convert Objects to NURBS is going to literally convert this SubD surface into a NURBS surface. And it will not delete it if you tell it not to, but you can see it's pretty, I mean, it's not bad. The poly surface that it creates is impressive. Well, let's go hide in the NURBS surface for now so you can just see the poly surface. Very organized. I mean, sure, we've got some stacking up, quite a bit of isosparms and knots, but it's smooth and it's exactly as I mean, most mesh conversion box modelers have some significant amount of distortion when you convert to a NURBS surface, and that NURBS surface is rarely editable. In this case, we're going to be able to, even with this super smooth surface, I mean, here's zebra mode for your viewing pleasure. I mean, it's pretty continuous, right? With this, you're going to be able to now actionably do some traditional NURBS modeling. We can now use those cylinders for our pen diameters, and we can use the base that we already created for our split commands. And honestly, the surface responds exactly like any other NURBS surface that I've ever worked with. It trims. When we are going to be cutting holes, I haven't had any major issues with filleting. And you can see here with the join, let's do some edge analysis. I mean, if it doesn't 3D print, it ain't worth anything to me. And you can see we have 0 naked edges, 0 manifold edges as well. And that's even after this join. So we're going to cut some holes and then we'll analyze again. But I can tell you that so far, within the realm of reason, I've been able to push this pretty extensively, and the surfaces remain airtight. So one-click 3D printing is not a bad thing for highly organic surfaces. Now, this is probably, I mean, there's no science to getting this done correctly. I'm just going to be placing in some cavities for the pens. Now, these pens are pretty particular. I have a series of drawing pens that I wanted to install, and I use Rotring technical pens that are drafting pens for really fine ink lines. So I want to kind of contain all of my primary pens in this top ring, and these were 12 millimeter diameter holes. And then I wanted to put another ring of 12s, and then the final base ring, I was thinking of going for a 15 millimeter diameter, just to accommodate some more girthier writing devices like some Copics. I also use mechanical pencils and some calligraphy pens, fountain pens of various nature. The main goal for me here was to kind of create a presentation piece. Now, in the end here, I'm not going to pretend like this is some finely designed item. However, in terms of design studies, I felt like this process, to me, went from CAD modeling and 3D printing and all the specificity of that process, it turned it almost into clay for me. Because I was able just to push and pull and squeeze and distort this shape into something fascinating and interesting so quickly and easily, honestly, it felt effortless. And because of that, I think that I would be much more encouraged to use this type of modeling process for iterative development. And that's something that we really don't usually do with 3D printing. I mean, let's be honest. You're supposed to make multiple prototypes and multiple changes, but usually you wait till the end of the process to develop the 3D model, and then it takes a week to do the model and the print, and by the time you get that back, you may have a chance to do one. Now here you're seeing me actually run a fillet command. This fillet was a little bit big, and it started to eke into that little isosparm over there, so I think I tone this down just a little bit. I don't want to push it too much, but I will look into how we can manage those relationships. Considering those lines fall on the faces, I do have control over that, so in the future. Now, the reason why I want to do this demo is because it really made 3D printing feel for the first time for me as a rapid prototyping development. Most of the time, 3D printing is this end result. And I have had opportunities to work on projects where I was able to make 4, 5, 6, 7 different 3D printed prototypes, but it took a significant amount of time and effort. And I feel that this process is so much faster and so much more complex in terms of what it can produce that it really has a lot of value to designers in terms of rapidly ideating objects and surfaces that are highly organic, something that was really only the realm of mesh modeling. And now I feel like we're starting to dip into those mesh modeling tools and still maintain the precision that we ask for and then frankly the practicality of a NURBS-based surface. The next step here is obviously STLs. So it was a very easy process. STL exportation had no issues. As you can see, I have no naked edges after all of the booleaning and filleting commands. No issues. And no flipped normals as well, which can be an issue with some of the more interesting plugins in the past with Rhino. For instance, T-splines was a product I used for many years. However, this beats T-splines all over the place, like in no comparison whatsoever. It is a much, much more powerful tool. And frankly, I look forward to learning a lot more about how these tools work. And one of the big workflow things I think is going to make this process really impressive is being able to lay those control vertices down. I think that's the change. So 2 days later, 3D printer working very hard for me and quite a bit more support material than I probably should have had. But as you can see here is this needle bearing. It is a impressive 105 millimeter needle bearing. I just had to use it. It was just too nice not to use. And having the bearing at such a large size means that when you move this object, there's no rocking. It's incredibly solid and incredibly smooth. Yet there is a bit of resistance. I wouldn't want this to spin forever. All those surfaces printed out. Sure, it's FDM, there's a little bit of stepping. This surface would be absolutely perfectly suited to acetone vapor smoothing. I'm definitely considering playing around with some acetone vapor to see if I can't get these ridges to disappear. And there it goes. It's pleasantly smooth and about 5 inches in diameter. And here we are. You can see that everything has its own little home. My Rotring Isograph pens, which I built this specifically for, are held very nicely in there. These pens are fantastic draftsman and technical pens. They're actually built on a metal nib system. You might be familiar with felt nib technical pens, but metal nib technical pens actually are, well, they last forever. They're all metal, and they are refillable in terms of their ink. So as you can see, storage of ink is important for those types of pens. The line they produce is incredibly sharp and incredibly crisp. You can't move quite as fast as you can with a felt pen, but I find that the fact that, well, it lasts forever is a lovely element. It's also something that you could put several different colors of ink in, and you're never buying ink cartridges, which are usually very expensive. Ink bottles are significantly less expensive, although you do have to use some Isograph and Tech Pen specific ink. It has a specific viscosity to it. It's also waterproof, which works really well with our Copic set, because Copics are alcohol-based, I believe. So I have found no issue with using these as underlays or overlays. And a few other little drawing tools you can see. We're just mixing up some ink. I like the Copic line of tools. I mean, I find drawing tools from Japan and Germany to be of great quality. The microns you can see there, I believe they were made by Pigma. They're also a really great option. Those are available literally anywhere and everywhere, but they do wear out over time, and that's why I like my Tech Pens. They just, well, they'll last for, I've seen Tech Pens 30, 40 years, still going. I mean, Rotring's been making that design for over 65, 75 years, so it's proven. I think the only way to finish this video off is to, well, let's do a little doodle. I've been making a few city skylines lately, and I figure why not let's do a little sketch of a little dystopian skyline of the future. I usually start off these sketches a lot like an industrial design sketch. Well, this wouldn't be considered traditional ID sketching. What is traditional? I start off with some light pencil just to give myself a few little scratches and guides for where I want to actually come in and draw in detail. And then I'm going to select a 0.3 millimeter Rotring for laying in my initial lines. I don't like to go too heavy when I first start off, but a little bit of detail here helps. And what you're going to see me is just kind of blast through this drawing. So sit back, relax. It'll be done here in a few minutes. And I want to thank you guys for taking the time to explore SubD tools. It's always of value to be learning new things and to be exposed to new things in the world of design. And I feel like every time I get a tool that really changes the way I look at something, I just have to share it. So have a great day, and enjoy my weird little sci-fi doodle.